Hello and welcome to stock system naming. Stock system naming really isn't a whole lot different than our typical ionic naming that we've been working with. It does involve crisscross and it does involve charges. There's a special case that we need to deal with, and this has to do with what are called transition metals. These are the metals from groups 3 through 12, those shorter groups in the periodic table. It is pretty important that you're looking at the periodic table as well as your notes while you're doing this video. The problem that we run into with some of these metals in this middle section of the periodic table is they have what are called multiple oxidation states, specifically multiple positive oxidation states. Now, there are other elements on the periodic table that have multiple states listed. You'll notice up here that I've put some non-metals. When we look at the right side of the periodic table, for our purposes, we're always going to use the negative charge that's listed first until we get to redox later in the year. Nitrogen, even though it has multiple negative listed, we'll still use -3 from that. In terms of bonding, we'll talk about why this is a little bit more later, but the problem that we run into with the middle metals on the periodic table is they actually do form these different oxidation states that we need to be able to deal with in our names because they affect our formulas. So just to give you a little example, I gave you the configuration for iron. And the reason that I gave you this configuration for iron is so that you could kind of compare it to what you see going on the periodic table. So according to the periodic table, iron can form either the charge +2 or the charge +3. And you can see that really your valence electrons are technically these 4s electrons, but you also have these very high energy 3d electrons. When iron bonds, it does some different things different ways. So we say iron has 2 valence electrons, and it's sort of true, but it's also sort of a lie. So iron might bond by losing 2 electrons, or might bond by losing 3 electrons. And you know, we can't, I'm not asking you to make that prediction, but we actually are able to figure that out using a special type of naming called the stock system, which is going to bring in some Roman numerals. So you do need to know your Roman numerals, so you can pause the video for a minute and fill in your Roman numeral chart, and be sure that you know these. We really probably will not go above 7, but you need to be absolutely comfortable and have these memorized up to 7. Take a minute and fill this in. Now, what the Roman numerals actually tell us is they actually tell us the charge of the metal. So this is actually not a hard type of naming. I think students try to make a little bit more out of it than it is. When we say the name manganese 3 bromide, this 3 right here, this Roman numeral 3, actually is just telling me the metal's charge is +3. You don't even need to look at the periodic table for manganese's charge here. So I've got Mn for manganese, and I've got Br for bromine. So as I assign my oxidation states, I'm all set for manganese. It's telling me it's +3. You're just going to be dying to look at the periodic table for manganese. You don't need to do it. When we look at bromine, bromine's only negative charge. Its top charge listed is -1. And then we just do what we did before. Boom. Boom. And when we do that, it gives us MnBr3. Now, we always want to be able to check ourselves here. So do we have a lowest whole number ratio? We've got 1 manganese, we've got 3 bromines. That's a lowest whole number ratio. Our manganese, that Roman numeral tells me it's got a +3 charge. Each bromine has a -1 charge. That absolutely cancels out to 0. So next what we're going to look at is cobalt 2 sulfide. So cobalt is CO, sulfur is S. When we're assigning our oxidation state, Roman numeral 2 tells me cobalt is +2. So if you look at cobalt in the periodic table, it has multiple charges listed. We don't need to worry about that. They're telling us it's +2. For sulfur, we use our negative charge of -2. Then we're going to go ahead. We're going to crisscross these guys, which gives me CO2S2. Then we say, oh, is this the lowest whole number ratio? No, it's not. We do exactly what we did with our other naming. This comes out to be COS. With the stock system, you're going to run into more that cancel because you have a lot of different oxidation states. So now we have a 1-to-1 ratio. I have one cobalt that's +2, one sulfur that's -2. These indeed add up to 0. So go ahead and take a minute and try each of these. Pause the video. So here are your answers for these. Most of these are fairly straightforward. Just keep remembering that, iron's charge here is +3 and oxygen's was -2. So we just crisscrossed these. Copper here was +2, chlorine's -1. It's just a crisscross. Titanium is +4, sulfur is -2. So this did have to reduce down to a 1-to-2 ratio. I just really like MOP. So this is +3 and -3, MOP, they cancel out. And then iron phosphate, so you get your iron with a +2 and phosphate with a -3. And, you have to still remember we're following our other rules as well, because we need 2 of those phosphate groups. We have to have that parentheses around that. Now, when you go formula to a name, when we do these separately, you'll know, oh, I need a Roman numeral because Miss Spencer told me to. We will actually discuss how you identify this when we kind of group some of our different types of naming together. So what we do first is we say, okay, I've got iron and I've got sulfur. The reason you need a Roman numeral is because iron has multiple charges. So we'll talk more about that identification later. But we actually have to determine what iron's charge is in this particular formula. So we have one Fe and we have one S. Because iron can be +2 or +3, you just can't take you just can't go with that. You have to be able to pick one based on what sulfur is. Sulfur's charge is -2. In order to balance out sulfur's charge of -2, iron would have to have a charge of +2. So you need to know that in order to assign your oxidation state. Oxidation, or your Roman numeral is always Oreo cookie style, goes right in the middle, refers to the metal. So this is going to be iron 2 sulfide. And I changed the ending to I, that's for step 4. We don't have anything here from table E. What's very important to notice, a lot of students think that the Roman numeral has to do with how many irons or how many sulfurs you have. Doesn't always have to agree with that. Your Roman numeral is 2 and you only have one of each of these. The Roman numeral is telling you the charge of the metal. So Ni2O3, we have nickel, and we have oxygen. So we have to go ahead and look up the charge of our anion because nickel has multiple charges, so it could be +2 or +3. So if it helps you to draw this out, you can totally do that. Since we have 2 nickels, I'm going to draw 2 of them. We have 1, 2, 3 oxygens. Oxygen is something I call a sure thing. It's always -2. There's no doubt in my mind that these oxygens are -2 each. If we add up all these -2s, they add up to -6. That has to be canceled out by our nickels. Total charge coming from nickel is +6, and there are 2 of them. So each nickel is going to have a charge of +3. So now I can go ahead and assign my Roman numeral for nickel's oxidation state. So this is going to be nickel, Roman numeral 3, oxide. And I'm changing that ending to I, as it tells me to do in step 4. Just one more note on this. Some people kind of look at this as reverse crisscrossing. So since this is a 3 here, that told you nickel's charge is 3. That can work sometimes, but then if you have canceling, it doesn't work. For example, it did not work in this example. So you ended up with a Roman numeral 2, which was not a subscript on either of those. So be cautious if you're doing that way. Please take a minute, pause your video, and try each of these out. You have nickel 2 bromide, because nickel, you have 1 of them, you have 2 BRs. Each BR's charge is -1, so this has to be +2, giving me that charge of +2. PbF2, each F has to be -1, therefore lead has to be +2 in order to balance that out. good old Mu3. So we have 1 molybdenum, 3 oxygens. Oxygen has to be -2. So in order to balance that out, molybdenum has to be +3. We have 3 Cls with vanadium, -1 each. So we have a charge of +3 for vanadium-3 fluoride. So there are also some of these that operate with what's called the common naming system. I did want to kind of take a couple minutes to talk about this because if you do a little bit more with chemistry, you may hear some of these names. The ones that I really want you to memorize are, I want you to memorize copper. I want you to memorize tin, iron, and lead. So this common naming system works under the idea that the lower oxidation state, the lower common oxidation state, ends in us, and the higher one ends in ic. So copper is either cuprous or cupric. So it actually takes the Latin name into consideration. Lead is plumbus or plumbic. So the lower charge of +2 is us, the higher charge of +4 is ic. Sometimes these are used, you do not use the Roman numeral with them. Sometimes these are still used and you might see them somewhere, although they are kind of fading away into the past. So it's just nice to be able to recognize these if you hear them. If we wanted to go back and look at some of the examples on the other page. So, not all of these are on here. If we looked at lead fluoride, for example, because lead's charge here is +2, this would be plumbus fluoride. If we went back and find another one's on here. So iron, because iron's charge here is +2, the common name for this guy would be, not right in red so you can actually see it, so ferrous sulfide. So this is not considered IUPAC naming, and in a lot of ways it's kind of gone to the wayside, but some of these, especially the ones that I want you to memorize, you still hear a little bit. So iron 3 oxide would be ferric oxide. Copper 2 chloride would be cupric fluoride. So again, we're not going to spend a ton of time on these. I would like you to know, I've got iron down here, so we've got ferrous phosphate. So again, just make sure that you complete this table in your notes. Oh, actually, never mind. I filled it in for you because I'm so nice. You just have to make sure that you go through and memorize iron, tin, lead, and copper.